In the last video, we saw how to specify the appropriate mesh distortion criteria and limits. This slide briefly explains the distortion measures, skewness, maximum corner angle, and the Jacobian ratio. The first pair of figures explain the skewness of a box. A skewness is a measure of the extent to which the volume of a box under consideration deviates from the volume of a perfect box. The perfect box is a cube with the same circumradius as that of the box under consideration. If V regu is the volume of a perfect cube-shaped box, and VE is the volume of a deformed brick element, then the skewness is V regu minus VE bracket divided by V regu. The second pair of figures explain the maximum corner angle. We know that in a perfect rectangle, all the four corner angles are right angles. As the element gets distorted, the corner angles change. A distorted rectangle is shown in the figure. The largest of the four angles is the maximum corner angle of a distorted element. The last group of figures explain the Jacobian ratio. It is a measure of the extent to which a rectangle or a triangle deviates from the perfect shape. A perfect shape may be an equilateral triangle, rectangle, or square, depending on the element shape under consideration. For example, an equilateral triangle or a rectangle has a Jacobian ratio of 1. The distorted triangle has one of its edges deformed such that the triangle begins to resemble a quadrilateral. This has a Jacobian ratio of 0.01. Similarly, the distorted rectangle has two of its edges deformed such that the rectangle begins to resemble a hexagon. This has a Jacobian ratio of 0.01. In general, smaller is the Jacobian ratio, greater is the distortion.